Hello, Assalamualaikum and welcome to my individual assignment presentation for Act3523. Today, I am demonstrating my step-by-step workflow for modeling the system development lifecycle of accounting information system using Gemini and Microsoft Project. In alignment to our core VBE principles, I am committed to total transparency, integrity, and operational accountability. This means I will show you my raw AI prompts, my logic verification checks, and exactly how I audited the AI data to construct an accurate real-world project schedule. We begin with Phase 1, AI Logic and WBS generation. To establish a robust baseline, I using a highly structured prompt, forcing Gemini to construct a word breakdown structure for our system based strictly on Marshall-Romney 5 SDLC phases. To prevent generic AI output, I applied precise structural constraint. The WBS must contain exactly 12 activities. Furthermore, I engineered specific operational bottlenecks. One activity in physical design phase must split into 3 parallel subtasks, and one activity in the implementation phase must execute across 2 parallel subtasks. As you can see on the screen, Gemini successfully constructed the 12 activity baseline metric detailing WBS IDs, description, and also the structural predecessors. Moving into Phase 2, Data Export and Management. Instead of manually typing out the data, which risks the transcript errors, I utilized the Export to Sheet feature for clean direct data portability. Now, this is where critical human accountability and validation come into play. During my audit trail, I noticed that Gemini initially calculated dates using the standard 7-day calendar week. However, a professional business schedule operates on 5-day works a week, meaning if an activity ends on Friday, the subsequent task must not start until Monday. To fix this discrepancy and protect data integrity, I using the prompt for Gemini to recalculate the entire timeline based strictly on 5-day works a week, running from Monday to Friday. This creates our synchronized data baseline, which you can see perfectly formatted in this Google Sheet. For Phase 3, I using Prompt Gemini to synthesize our clean data into visual project management benchmark. Here is the AI-generated Gantt chart. It is used a distinct 5-color palette to represent the Romney SDLC phases. Notice how the parallel subtasks in the physical design and implementation are displayed as overlapping horizontal block, visually mapping out our project concurrency. Next, I had Gemini generated our project network diagram to map out the strategic logic. This diagram clearly visualizes our operational junction. Look closely on 2.0. It creates a clear fan-out where our three parallel database UI, UX, and infrastructure tasks branch off. Further down, you can observe the fan-in where the parallel coding tasks merge back together seamlessly on Node 4.3 for system conversion and data training. These two images serve as our absolute analytical benchmark. Finally, we arrive at phase 4, Microsoft Project Validations. To prove the logical accuracy of our workflow, I replicate the 12 activity WBS exactly inside Microsoft Project. First, I adjusted the project calendar to standard 5-day work week to synchronize with our corrected AI benchmark. Then I entered the durations and meticulously linked the predecessor to recreate the exact parallel pathways. As I switch to tracking views, take a look at the side-by-side comparison. The Microsoft Project Gun matched our Gemini benchmark flawlessly. The dates, the color, the transition, and even the overlapping tasks align perfectly because we caught the calendar constraint early on. Same goes for our network diagram. The structural fan-out and fan-in logic modeled by Microsoft Project mirror the AI benchmark node for node. By highlighting the critical paths in red inside the MS project, we can execute our critical path analysis. The most time-sensitive chain runs through the system analysis, conceptual design, our longest design subtask, our longest coding subtask, and directly through the deployment. Any delay along this specific path will shift our entire completion date. By taking full ownership of the technical logic and refuse to take a blind AI shortcuts, I have successfully synchronized a conceptual AI model with a rigorous technical Microsoft project schedule. This concludes my presentation. Thank you, Doctor, for your time and guidance.